Thanks very much for the kind introduction. My talk will be much easier compared to the first speaker because it deals with stuff that surrounds us each and every day. I've been looking at people around touching their cell phones, some are WhatsApping and stuff like that, but all that information could be utilized. We could extract useful things from it rather than just looking at pictures and videos and stuff like that. So mine is just focus on that, and it's going to be straightforward. It's a pity that this is always referred to as a talk. I prefer interacting with my audience so that I can see whether they're still listening or not. But I'll just continue until the end, and I hope you'll have interesting questions because this is a work that has to keep on continuing. My outline is obviously you need an introduction on big data. We always confuse big data with data science. I'll try and clarify that. Data quality issues, intelligent systems. We're going to be looking at experiments to show the impact that data quality can have in the systems that we used from time to time. Then obviously there'll be just some conclusion as the way forward in terms of Africa and South Africa as well. I always give references to show that this work is not just me. I had to go around and reading as well, which is something that you guys should do as well. Then there'll be a quote in relation to that. Introduction-wise, 200 BC, data was there. That was even before Christ. It's amazing. But of very low quality. We move on, 1956. Just look at the gadget that's carrying data. It's still fine, but it's not of good quality. But you can see that things now are getting smaller and smaller, as you see on my next slide. 2018, now we've got data stored there, very high quality. And we've got analytic tools now that can able to sort of like analyze that kind of data. 20 years from now, or 10 years from now, I believe that data will be sort of like stored, available in sort of like digital-wise, and it's going to be excellent. That's my vision. It should be excellent, and state-of-the-art analytical tools should be able to analyze that kind of data. So we can see that data is always going to be there, and we keep on generating from time to time due to technological advancements, and at the end of the day, we need to have sort of like storage for it. Basic projection in terms of the stuff that we do, predictive analytics, you can see that expertise, knowledge, and intuition is quite critical. We always forget about intuition. Every time you do an experiment, you should have a hypothesis on intuition at the top of your head, just before you even start the experiment. But the experiment should be able to, whether it contradicts the hypothesis or it supports it, it doesn't matter. What I normally see people is whenever the hypothesis doesn't go along with their results, they cook the results now, which is absolutely wrong. At the end of the day, that's why we do experiments, is to show that sometimes statistical theory or whatever theory that we use from time to time can be contradicted by the data that we use. So it's very important. Data science in Johannesburg, I use Johannesburg because I'm at University of South Africa. You can see that data science is there. We need mathematics, computer science. Then there's domain kind of like enterprise as well. In terms of data analytics, what do we really mean by data analytics? Analytics, I always refer to as the use of data, information technology, statistical analysis, quantitative methods, and so on. But it helps managers to improve kind of like insight about their business operations. It's very useful. I mean, here's a data set you have. How can it give you an edge in terms of your competitiveness in business? Okay, then, sorry about that. Then business analytics is a subset of data analytics, and it's been quite utilized as well. However, in as much as we use this and we're extracting information, things might not go according to plan. I did highlight the issue of fraud, where people cook results. That's what we refer as Ben-Forini principle. We've got a data set, but it doesn't give us what we thought it was going to give. For example, in terms of patterns that are going to be meaningful to the study that we're doing. Ben-Forini explains that quite well, that it's possible that's going to happen from time to time. These are industrial demands that we currently sort of like faced with, not just as Africa, all across the world. We want safety, healthy decisions that we make, efficiency and stuff like that. All those things are stuff that we have to keep on doing in order to support our problem that the country or the continent is faced with. This is a good example. In as much as we get excited about AI, big data analytics, there's always going to be critics. For example, the people who believe that killer robots could be outlawed, robots could replace half of the jobs in 20 years' time, artificial intelligence could spell the end of the human race. That's Stephen Hawking who said that. That's fine, but we always have to keep it at the back of mind that we shouldn't panic. Why am I saying that? This is the quake that AI has made in recent years. China is investing 337 billion. AI is in the top 6 trends. Every time you go to the World Economic Forum, there's bound to be a topic on AI or the 4th Industrial Revolution, which is part of big data, kind of like analytics as well. So it shows that AI is there, and it's already making some sort of like waves. Also, we read it on the daily news from time to time. Now we can assess breast cancer 30 times faster than before. That's AI for you. The voice recognition 3 times faster than typing. That's going to be AI for you. All those things are not made by me. You can Google them. That's why I've got the links there so that you can go and read about them as well. Self-driving car. I know that there's a car that knocked down someone in America, dead, but you're going to improve on that. Maybe in 5 years' time, cars won't be knocking people down and things will be fine as well. But there are quite a number of things that things have sort of like made headlines in terms of AI. In terms of data volumes, driving AI, you can see that it's increasing day by day. They assume that 26 billion Internet of Things devices will be in existence in 2020. How are you going to be able to analyze that? How are you going to be able to analyze that kind of like data set? So that's why AI becomes important. But what are the characteristics of big data? People always forget about veracity. Volume, it's fine, it's straightforward, it's easy to understand. Velocity and variety. My focus has always been on veracity. How good is the data that we use? All the conclusions we made on data, are they sort of like solid, given that the data is of good or bad quality? So for me, it's very important to be sort of like looking at that. Who's generating data? Facebook, YouTube, Twitter. We also have scientific instruments. The first speaker did talk about the SKA project. Massive data sets are coming in there, and they should be sort of like analyzed. We've got mobile devices as well. I've already talked about that. Sensor technology and networks as well. All those things, they lead to innovation. People can be able to manage and analyze it and summarize it to discover sort of like useful knowledge. Structure of big data, everyone's favorite is structured. All you do is just run the data, there are no complications. It's always given in sort of like related format. But if you go to semi-structured students, they start running away now, because now you've got data that can be analyzed straight away. Then there's data that you have to manipulate in order for it to be sort of like analyzed. This one is always complicated. How do I analyze a video? How do I analyze sort of like a picture or stuff like that? How do I and this is quite common in biometric exercises. How do you detect diabetes through the eye? I mean, it's quite fascinating. So that's sort of like unstructured, because it's a picture that you'll be looking at, but you should be able to extract useful information from it as well. So those are the things. So in terms of big technology, I like that high performance is very critical in terms of the data sets are massive, but how, in terms of infrastructure, do we have enough infrastructure to be able to accommodate that? Hadoop is able to deal with that as well. I mean, CSIR in terms of high performance, they've got a supercomputer which we could utilize. I think it's remote access as well. So everyone can be able to sort of like use that, because at the end of the day, infrastructure is very critical in as much as we're collecting this data. In terms of data quality, you have a problem if data doesn't mean what you think or it should. So me, that's one of the key things that we should be able to keep at the back of our mind. Many sources and manifestations. So that's another thing as well. Data quality problems are very expensive. Companies are spending loads and loads of money to be able to sort of like clean their data as well. Here's a good example. How do we interpret that? I mean, you've got a data set, my initials and last name are there, and can you be able to interpret that? What do the fields actually mean? This is what's given, but you should be able to extract useful information from it. Data glitches as well, metadata and domain expertise. Those are kind of like examples in terms of that. In terms of continuing in terms of real world, you need a data management system that's going to be able to deal with these quality issues as well. So some of the things I'll just browse through, but you can have my presentation. You can just email me and I'm able to send it to you. So there are a couple of dimensions in terms of data quality, validity, reliability, completeness, precision, timeless, and integrity. All those things you might have to consider when looking at data quality issues. Good data and should be valid and reliable. The first one, you can see that everything is all sort of like out of place. You come to the next one, it's reliable because you can see that there's some sort of pattern that's followed. But the third one is valid and reliable because it's all contained in one. And you can see that it's a much kind of like solid pattern. So that's what we mean by valid and reliable. Data glitches, there are many causes for data glitches. Systematic changes to data is one of them. Then obviously you need a framework to be able to enhance data quality. That's the framework that I've given, the source, the collection, the collation, the analysis, and the reporting as well. In as much as we collect the data, you have to come up where you have to report it so that people can understand exactly what you're trying to do as well. So technical approaches that people have followed, it needs a multidisciplinary approach. It's not about statisticians or data scientists as well. You have to involve other fields as well. Psychologists have played a major role now in terms of collecting data. So it has become kind of like useful. So multidisciplinarity for me, that's the way forward. It's high time that we don't focus only on quantitative stuff. We need the qualitative stuff as well because they are the ones who are going to go to the field and be able to do things as well. I always refer to this as kissing a lot of frogs to find a gorgeous princess because when people said these things some time back, people were just saying, wow, this is quite interesting and it could be possible. 20 years later, this doesn't make sense at all. Bill Gates, for example, he talks about 650K to be enough for anybody. But now we're talking of terabytes. But when he said that in 1981, people think, yeah, this is quite interesting, and it is really. So those are things that I want you to keep at the back of your mind, that some of the stuff we discuss now, when the people hear about them 20 years from now, they say, what was wrong with these guys? You see, so that's one thing that you have to sort of like think about from time to time. In terms of intelligence systems, this is just an overview that I'll give you so that you can have an idea. What do you mean by intelligence? I mean, you read this all the time. For me, it has to have several characteristics. One of them is reasoning and learning and adaptivity as well. So once you have that in place, then you can start talking about an intelligence system. I like the idea of Turing. Turing is one of my inspirations as to why I decided to do artificial intelligence, whereby this is the guy who managed to crack the World War II code. That was in the 40s or 50s. But already AI was in existence. People talk as if AI started today. But Turing managed to do those kind of like things. The Turing test, you have heard about it, where computer can be able to pick up whether a voice is from a female or a male. If it managed to sort of like smart a human being, it means the machine is sort of like smarter than a human being. It sounds so basic, but that's the whole idea that Turing came about, that if a machine is able to do things better than human beings, then it has to be sort of like smarter. So that's all the concept that he came about. I'll skip this slide. Cognitive science as well has become sort of like important in the field that we do. I did talk about multidisciplinarity, but where you're going to be able to do cognitive science if you don't involve psychologists in your research? Big data, in as much as important, we need psychologists on board. So that's why I've sort of like highlighted the philosophy as well. It's very kind of like important. I wouldn't ever overemphasize the issue of multidisciplinarity as well. It's very kind of like important in terms of that. So now, in terms of background, we have read about the McKinsey report where he highlighted the importance of big data, and there are others that have come up as to why big data analytics is very important in terms of moving forward. However, as I've argued elsewhere, big data is not a solution. It's what you do with it that counts for me. Because it also carried risks. Risks of big data, we are so overwhelmed. As we're sitting here, data is streaming in and out, we don't even know what to do with it. Costs escalate too fast. How do you deal with it? Infrastructure-wise, how are you going to be able to sort of like accommodate that? There are also issues of privacy as well. Go to banks today, you want to do a study, you need data, they aren't going to give you that data. Even if you sign confidentiality, all those things you have to keep at the back of your mind. Even medical records, it's difficult to get them from hospitals to do research on diabetes or other diseases as well. So all those things are one of the things that are risky in terms of big data. So two kinds of big opportunities: computer science through data manipulation. We need computer scientists to manipulate the data. Statisticians, we need them to do the inferences, because all the time, whatever conclusion that you come up with, they have to have some statistical or scientific justification. That's why it's important to do some inference on that. The challenges of big data, obviously computational and mathematical challenges. It still surprises me that we don't have a degree in big data at our universities. It only starts at master's level. Imagine if we're a module, even at high school, because we deal with data all the time now, whereby kids can start learning about it from high school before they reach university. But now we focus on masters. So all these things will come into sort of like play. Inferential and statistical challenges, that's some law that I came about in terms of power, that in as much as we get all this information, the power itself, it keeps on increasing each and every day. Once you think that you have clinched, you've sort of like made it, something else is going to happen, and the power has to keep on like increasing all the time. So then data challenges, I've already highlighted that my focus is on data quality, and there are other things that are a challenge as well in terms of data. So now aim of this talk, I've already spoken for 30 minutes. It's only now that my talk starts. But the whole idea was just to give a background as to things that we always confuse from time to time. So the focus is just to show about pervasiveness in big data opportunities, leading to misleading conclusions, incorrect understanding, mistaken decisions, and absolute waste of money, because you're collecting this data, but at the end of the day, it's not of good quality. And to show what's needed to sort of like tackle it. So this is the problem of poor data quality. Here's a good example, potholes. I talk about problems that I'm faced with time and time and again, whereby you need a smart sort of like phone app to be able to detect whenever there's a pothole. So for me, that's one aspect that you can use. You can use GPS all the time, enabled to determine that. Hurricane Sandy. There are a lot of tweets going up and about when Hurricane Sandy sort of like hit America. That was one thing that really made me realize how data can be very useful in terms of sort of like communicating. This one is, it's much common. You always apply for loans all the time, but you keep on getting rejected. But you're building a model which decides whether you're going to be given a loan, that characteristics there, but at the end of the day, you are rejected because the model is built on historical information. It's not built on you as an unknown instance. So that's another one that has been used in terms of that. So what drives poor data quality? Data entered by employees. We have got employees here, they do things manually. So you're bound to sort of like make mistakes. Migration and conversion progress, migration of new systems. Time and again, our sort of like organizations, we change systems. There's migration of data all the time. And at the end of the day, we tend to sort of like lose track as to what's good and what's bad in terms of the databases that we sort of like develop. Mixed entries by multiple users. You find that you've got different kind of like users, but they've got sort of like entries that has to be sort of like sorted out in sort of like a database. Changes to source systems, systems errors as well. So those are things that are quite common in terms of data quality. These are problems that are key when you're looking at artificial intelligence or machine learning. One of them is noise and overfitting. That's a data quality kind of like problem. Missing values, incomplete information. That's another problem that as machine learning researchers were faced with from time to time. Then there's this bias variance problem. I'm sure you guys have heard of it, whereby people can't decide as to whether to go for bias or the variance. That is in terms of errors that your system is going to be able to sort of like come up with. Learning as such, and there are other problems as well. Another one which I forgot to mention here is the accuracy versus computational cost problem, whereby people will say, I'd rather have an accurate system that will run for the whole year than to have a system that's going to be slightly good, but to run within 1 second. So that's a debate that's been going on. If you have got students, you can make sure that they do research on that. It's kind of like a problem that has been sort of like faced with. So this is the problem that's caused by incomplete information. You can see that on this slide, everything is fine. There's no incomplete information. What you're trying to do here, you're trying to predict the cause of death. I've highlighted 3 key sort of like attributes that are important. Age is important when you want to look the likelihood of the cause of death. Marital status, gender as well. But if you see the right-hand side, what if this information is missing? How are you going to be able to classify an unknown instance? In other words, how are you going to classify me if age is not there? At the end of the day, you have to make a decision, but that information is missing. To make it even worse, gender is also missing, but you still have to classify that. So that's the problem I've been working with for the past 20 years, whereby I assume that, there's missing information, and I'm going to be able to classify that. But this is just a hypothetical example of predicting the cause of death, given all this kind of like attributes. So to do that, this information is very important. One of them, proportion, that's the percentage of the missing values. It could be 5%, it could be 10%, it could be even 50%. Half of the data, there's nothing, and there's missing information. Then you have to look at the pattern. Is it missing on one attribute? Is it missing across attributes? Or is it just a monotone? That's like a certain pattern that it follows within the data set. Then you have to look at the mechanism. This is one of the most important aspects when you're looking at missing data, whereby people talk about missing completed random. You guys, I'm sure you've heard of this, and it confuses you to hell. Missing at random, you see this concept, but what do they actually mean? And informatively missing. Missing at random, basically what you're saying is the fact that information is not there has not been caused by anything. It could have been a dog that just ate the questionnaire. It's got nothing to do with you. That's why the information is not there. Missing at random, it means that there's sort of like dependencies between the attributes. Age could be related to gender, or blood, sort of like glucose. Let's say you're looking at diabetes, could be related to glucose. The fact that glucose is not there, that's why you can't have information on diabetes. So there's dependencies between the variables. So that's what missing at random means. Informatively missing, you may find that people with diabetes, they don't reveal their status. They just keep quiet. Before it was HIV, because it's a stigma. So I'm holding back, even though I know that I'm HIV. So that's why it's informatively missing. So that's what all this sort of like probability of missingness are driven about. So then the methods that have been used, list-wise deletion, pairwise deletion, there's single imputation, multiple imputation, and supervised learning. These are methods that I used the classifiers, the neural networks of this world, the decision trees, to impute the missing values as well. So, but all these are methods that are out there that you can use as well. So then the whole concept of the methods that I use, or I use with my students, is I always say there has to be some dependencies. The fact that something is missing depends on the other variables. That's why I talk about a Bayesian expectation. I call this sort of like an optimist, and I call this a pessimist, because this one is not conditional on anything. For me, the missingness could be critical, could be holding vital information for me to develop a new technique. So that's why I prefer to call it an optimist. In other words, I assume that the missing information is critical. So this experiment we did with my student is a master student. We're looking at the causes of death. I just want to highlight to you the impact of poor data quality as the damage that it can cause. As you can see, we had 456 deaths. That's our instances. Small data, you can argue, but running it on a system, especially on MATLAB, took us for almost 2 weeks to run. So obviously, if we talk of big data, that's nothing. I mean, but that's what's kind of like a start. So these are the causes of death. We split it up into 10: TB, diabetes, various forms of heart diseases, cerebrovascular diseases, HIV, other causes of accidental injury. All these are just causes of death. 5 natural, 5 unnatural. So what we did, we split the data random into 10 parts. Remember, as big data analysts, it's important that your experiment, you should always keep at the back of mind that it's a random experiment. If you run an experiment once, and I give it to a student to run the same experiment, we'll get different results because it's at random. So replicating the experiment becomes important because it takes care of the uncertainty that it's random. So what we normally do with my students is either we take 10 sort of like replicates, or we use 5. But the more replicates you make, the better the experiment. In other words, in machine learning terms, they call it the validation part. You train, you test, you validate. So it's important to be able to do that. So I call this a tenfold cross-validation. Obviously, I did talk about, I keep on pressing the wrong button here. I did talk about the true suits. This is what drives the missingness, and the proportion as well, and the pattern. Remember, this aspect has to be covered to show the impact of each. Does pattern matter when you've got missing values, or does the missing mechanism matter as well in terms of that? Then what we did, we split the data into 2, half of the attributes, and then all the attributes, about 120-something attributes. So you can see that it's quite a lot of kind of like work. Then we generated the missingness ourselves in terms of the different kind of like mechanisms. The results we got are quite interesting. You can see that as the proportion of missingness increases, the error also increases. You can see that starting from 0, the error was quite low. But the more missing values you have, the accuracy of the classifier, sort of like that's the error that you're going to get. If you look at, these are the different methods we use. Combination of trees and single mutation methods. You can see that informatively missing has got more impact. So in other words, for people holding information, that's got a huge impact on the data set than missing complete random, or someone just not filling the questionnaire because they just couldn't be bothered. But missing at random, reasonable. It's on the sort of like center line. You can see that. Coming back to, that's only all the attributes. Half of the attributes, you can see that the error rates are higher. In other words, the fact that you had attributes on half of you have missing values on half, the impact is more than when you have in all. The argument you'll say, maybe where you initiated or you simulated the missingness, those variables have got nothing to do with causes of death. They don't have impact compared to that. But that's another study that you're going to be doing. We can increase the missingness in the variables. Instead of looking at half and all, we can start by 1, which is univariate, and then move to the second one until we do all. But it's a lot of work. I always include this graph to show how good the predictive model is. I mean, you can see that it approaches almost 10 or 90% in terms of the predictive analytics, in terms of the model that we use. So it shows that the models are fine, there are no problems with it, but at the end of the day, the impact is there in terms of missing values. As a way forward, African corporations, I believe, cannot afford to miss this opportunity in big data. The fact that we've been lagging behind compared to Europe, US, and even Asia always worries me. But at the end of the day, you can show that we're making some strides. But the only problem that could be contributing to this is the skills gap in Africa. I've just highlighted to you that we don't even have an AI degree, first degree in our university, not even one university. We can have a module, but not a program. But we want to be able to, we talk about the 4th industrial revolution. So for me, that's one aspect that we have to sort of like look at. Culture, we need a culture that supports big data. I'm sure we want our kids to know that as they use their cell phones, they are collecting data, or as they read messages from WhatsApp, that's data. So for me, that's the culture that our kids should have as well, and how they can able to use that. We also need new innovative methods of data collection so that they're of good quality. We can utilize the West. They've got very good programs. I know IBM, Wolfson College, they've got interesting programs that you could sort of like use in terms of data collection methods that we guys can use in Africa as well. Efficient distribution of resources by African governments. I mean, you can see that there's a lot of money involved there. 3 trillion available to be earned through big data in countries such as Europe, United States, and Africa should be playing a role there, or should have a chunk of that kind of like trillion, or be part of it as well. So my question then I pose is, are med skills enough to be a data scientist, after all? And the issue is that stats is important, programming is important, ability to build models, and ability to work with systems, for me it's important. But you always forget this skill, communication skill. So I expect someone to come here and demonstrate the work that they've done. We expect our students to do the same as well. In as much you can be a data scientist, do all sorts of fancy things. If you don't communicate things to your CEOs or directors, they're not going to give you funding for your project because you don't explain things in a clear manner. This is a problem that I've sort of like picked up with our students. They can't communicate, whether orally or handwritten. So that's a skill that we should sort of like beef up, especially at our universities, in terms of moving forward. Almost the potential for big data in Africa. I mean, there are countries that have made some strides, Kenya, Nigeria, South Africa as well. We know Discovery, they're quite sort of like passionate about analytics. They come up with all things, but their main sort of like advantage, they look at our perceptions, how people perceptions change over time. Discovery have mastered that. Discovery can pick now that, oh, this guy is giving talks in Cape Town. Maybe it's high time I give him discounts to Cape Town. So that's how they move. Or this guy goes to the gym a lot. Let me link it with Virgin. That's what they've done, perceptions. So I like the way that the stuff that they're doing. And even their bank will be based on that. I'm sure you guys have heard that they're currently working on that. So all those things, it shows that Africa has made some sort of like progress in that. So there are projects that we do. I am marketing UNISA. So these are projects that we are currently doing at UNISA. Some of them are almost to completion. We've looked at fraud analytics, Bitcoin. Everyone is talking about Bitcoin. My friends come to me all the time. They forget about the fraudulent activity that takes place there. You can use AI to be able to detect that. So that's one aspect of it. Recommender systems, process information, error analytics. You'll be amazed the performance bonus thing, how it's impacting on business. There's a student working on a master's, looking at that as to, is it has to be bonus versus performance, or the money doesn't have to count because you are doing your job after all. So we're looking at attributes that contribute to that. People are resigning because of that. Then these are stuff I'm doing for Johannesburg Water, detecting early pipeline leakages. They've got huge problems in terms of leakages, Johannesburg. So I've got students working on that. All this is, I need data from this kind of like companies to be able to do this. So it just shows that we can do a lot. The good thing about it, the president now is weighing in on big data analytics, or fourth industrial revolution, which is part of analytics. You can see that he made a huge statement on that. Rapid technological change. And however, allocation of spectrum, we're still lagging behind. All these things I'm saying is driven by connectivity. So spectrum, internet connectivity, if it's bad, we're going to struggle. So it will be nice to meet the president one and say, it's high time that we have got 5G. You push that agenda, that we have 5G, so that you can drive the fourth industrialization agenda as well. For me, that's kind of like the way forward. But the good thing, we have a president who can see now that this is the way forward, and he's very passionate about it. Even the minister, they've appointed a minister where they've merged ministries because they want to address this. Obviously, sustainable development goals in terms of AI are very important. Food for thought. When you leave this room, just keep these questions I'm posing here until we meet next. The issue here is, do you think all this, what Begi is saying, makes sense? Do you think Africa can really benefit from this? Just think about it. What about the 80% of companies? Will they need to change, or are they going to crump if they're not sort of like taking sort of like AI into consideration? What are the implications to society? People at especially in rural areas. All this, we're talking about it, but what's going to be the impact? And can it achieve sustainable development goals? That's a food for thought. That's for you to think about from time. These are the skills that are needed here, guys. I think it's high time. I always include this slide so that we have an idea as to how big this is. You can see 2015, these are the skills that was required for Industry 4. 2020, these are the skills we need. But we're still talking about lowering pass grades in mathematics. How can our students survive if we're talking about all the skills that are required here? So let's keep that at the back of our minds as well. Key references, these are things that I've read, to prepare this. Of course, I can't leave my own reference here because it means a lot to me. That's work that I've been doing for a while. In fact, that's part of my PhD. I've been doing a lot of stuff on sort of like data quality issues. This is a good code I like. Whether you like machines or not, this Claude is saying it's going to be rooting for the machines. Yeah. Thank you.